Hi there, I'm Professor Rafael Bonato, and I will be with you during the module number 7 of a food chain training. Today, under the Sustainable Food Production System, we'll be talking about digital technologies for data-driven agriculture. I really hope you enjoy this class, you take the best of it, and learn and read through the documented data and the written data that's available for you. Let's start. Our first slide is about the learning outcomes of such a module, which has been divided into 5 different outcomes. At the end of this submodule, students will be able to explain the role of digital technologies in modern agriculture systems, the first one, describe how sensors and drones monitor crops, soil infrastructure, and equipment, interpret digital data to support agronomic decisions and preventive management, assess how digital tools improve sustainability, efficiency, and loss prevention. And the wrap-up as a learning outcome relate digital agriculture to European Union Farm to Fork, Common Agriculture Policy, and Green Deal objectives. Let's start with our first slide on the introduction of such a module. As our first theme here, we'll be exploring digital technologies for data-driven, and it's always essential to emphasize that this material here acts as a pre-introduction to the knowledge that you will be able to access once to reach the material that has been drafted and shared with you. On such a material, the bulky information, you'll be able to find the links to the international publications such as journals, scientific journals, publications on magazines, and etc., that will reinforce each of those concepts that I'm just about to share with you. Okay? As an introduction to this submodule specifically, digitalization is transforming agriculture from periodic observation, periodic, and uniform inputs used to continuous data-driven management. You see, it's incurred a cycle. Okay? Within the EU, digital agriculture supports strategic goals and relate to pesticides reduction, nutrient efficiency, climate resilience, and food security. These are essential pillars for the European Union Farm to Fork strategy, Common Agriculture Policy, and all the policies that actually are driven by European Union. And the last paragraph here, sensors, drone, and digital platforms enable early detection of stress, inefficiencies, and failures, shifting management from reactive correction to preventive decision-making. You always act as we're looking at acting under a preventive decision-making approach that before the problem happens, you act, okay? Instead of being a reactive, doing after the problem, you act before, okay? Before it actually happens. This subchapter here is related to the chapter you have in a document, which is the second chapter of digital agriculture as an enabling system. We see that the digital agriculture acts as a mechanism for facilitating our daily life as a farmer or maybe an operator of food industry and etc. Okay? Digital technologies do not replace agronomy. They enhance agronomic insights by. These are 3 points I'll share with you, but keep in mind that when you have innovative tools put together with the techniques that you already know, you have something the way stronger than the business as usual person that normally don't do such integration, okay? 3 of those benefits of digital agriculture can be named as providing real-time, spatially explicit data, so you understand what's occurring on the right time, and then you can take action accordingly. Revealing variability hidden by field averages. Normally we look, example, production at the paddock level. I have an average production of 4,000 kilos of soy per hectare. That's an average. But within such a paddock, I can actually find spots that produce more, spots that produce less. Once I have those tools, such as digital agriculture, working for me, I'll be able to understand and review such a hidden variability and act accordingly. to suppress problems and enhance solutions, okay? And again, supporting targeted, efficient interventions, how to intervene properly on the right time, on the right manner, okay? Digital tools function as decision enablers, not autonomous solutions. We are not looking at a miraculous solution. We are looking at a group of solutions that actually deliver a holistic approach. This figure here on the right-hand side has been depicted, has been extracted from a scientific paper, and then just happens to organize data acquisition, ranking, and actuation, okay? These are the components of the systems based by sensors, based by data, based by decision systems that you can actually go through this paper and read in more in depth and understand how digital agriculture is so essential and so important nowadays, specifically on the days that we have some very hard challenges played by the changing climate, okay? The next slide, sensors in agriculture production, very important. This chapter here, the objective is to express that monitor soils, crops, and infrastructure continuously as a first and most important thing to reduce stress and losses and input waste. Specifically, the sensors to make such a things happen, like the sensor in agriculture productions, they can be set in different parts of our production system, from soil sensors, plant and canopy sensors, and infrastructure and equipment sensors. You see, you departure from the soil, you go all the way to the equipment sensors, the infrastructure, okay? You see sensors, they act transversally in many different areas. Just here, one example, you can see that Smart Plant, this is part of a scientific paper that talks about soil and plant sensors and help us understanding, example, from the leaf structure to the root structure to the soil sensor structure for nutrition, water retention, and etc., pH, and etc. This paper is very interesting, and I strongly advise you to read with attention because explain how those many different types of sensors, such as crop hormones, nutrients, moisture, disease, environment, growth, as well as soil nutrients, moisture, pH, and pollutants, they can work all together under a given platform that will help you with your decision making on how to apply, what to apply, and when to apply, okay? Just to give you an example of sensors, okay? Focus on a soil sensor in this case. They provide the real data on moisture availability. Example, in brackets, you can read irrigation scheduling. Helps you schedule the irrigation on the right time and the right amount and quantity. Temperature for germination, microbial activity. If you understand how the temperature is acting, is influencing, you actually understand how the microbial activity will be. Remembering that from our class, the module number 4, I have mentioned that the microbial, they have the optimum temperature. Example, bacteria and fungus, they act in different temperatures ranges. If you understand that, you can actually fight them back or maybe benefit some of the beneficial microorganisms, okay? Electrical conductivity, texture, salinity, nutrient variability. It's a type of sensors we use on soil for decision making. And one of the top one, all of the sensors are important, but this one is very important. Compaction and aeration status. If you have a sensor, if you are able to use a sensor for soil compaction diagnosis, identifications, and aeration status, you actually understand how the soil structure is, how the water is flowing and percolating, how the plants will be able to access such nutrients and etc. Okay, this is so important. And this paragraph here just reveals sensors based on soil monitoring enables demand-driven irrigation. Okay, you're not just irrigated because you want, but it's demand-driven. Fertilization as a demand-driven as well. Cultivation, reducing yield losses and environmental impacts. It's so important having those sensors in our soils. They help us a lot. Okay. Plant and canopy sensors. Plant-based sensors capture crop physiological responses, including chlorophyll content. Chlorophyll content can be directly related with the nitrogen status. You know, the chlorophyll is composed by many components, and one of those very essential for formation and stabilization of chlorophyll is a nitrogen. By understanding the chlorophyll content, you can understand how much nitrogen you have in a plant and have to apply more or less on, that's very important. Canopy temperature, you have the canopy on a tree. If you understand the difference between the ground, the middle tree, or the canopy temperature, you can understand how the fruits located at the canopy height, they are actually behaving. How to maybe control the area, how to harvest now, maybe harvest in another time, decide to harvest early morning, afternoon, or night. That will always help you. Such as sensors, they'll help you taking the right decision, okay? Spectral reflectance, the biomass in vigor. It's a more high level, more scientific data, more scientific information that help you actually understanding more on a broader and more in depth, with more rigorous information, how to take the decision. This is a more scientific, as I mentioned before, but they be sure that they help you a lot understanding what's going on the temperature, what's going on the bricks, what's going on the fruits that are located at the canopy height. And here, the vegetation index, such as NDVI, we use it for pasture and for temperature of the soil, NDRE, enable early detection of nutrient stress, water deficit, and disease pressure, often before visual symptoms appear. These technologies, they help you position yourself, like the sentence say, before you actually sighting it. Because sometimes our eyes are not able to detect, only able to detect when the damage is caused. But if you have those sensors playing outside, we can actually detect it before it happened. NDVI is one of the examples. A lot of people, a lot of ranchers, they use NDVI for pasture to define the height of the pasture, the sward height we call it, and the moisture, humidity of the pasture to decide when to move the cattle around. So you don't have to go there. If you have NDVI imagery, which comes from a satellite, specific satellite, you can actually take the decision before it gets too dry, before it gets to the amounts of fiber too high, and etc. Okay? Sensors for infrastructure and equipment monitoring. Digital sensors also support machinery health, like vibration, temperature, operating hours. You can actually take in the machinery health is if the machinery is working on the right temperature, if the lubricants are correctly, and etc. Okay? Digital sensors can support as well irrigation system performance. Nowadays, the majority of the irrigation systems on the big crop lands in South America and North America, in some areas of France, Italy, and Spain, they operate 100% on sensors from irrigation system performance to understand if the pressure on the nozzle here and over there are the same, if the flow is correct, if there are any leaks on the pumps, on the pipes, and etc. So, and normally adopt that using the sensors because it's hard to have a people able to go on the field and check each of the nozzles. The system itself saves you of going there, actually putting you to work in something that requires more knowledge, okay? And the other digital sensors supporting figure is that storage conditions to diagnose and understand any problem of temperature, humidity, and gas composition. Those digital sensor helps you without actually going there. If the sensor is there, they communicate you on your database, and then you can take the decision at the right time. And the wrap up of this paragraph, condition-based monitoring, reduced unplanned downtime, prevents spoilage, and improves operational continuity. Remember, you have something to be continuous. If it stops, you're losing energy, you're losing labor, you're losing product and generating waste, okay? The scheme on our right-hand side represents AI-driven, artificial intelligence-driven data processing and control, how it receives, how it processes, how it controls. And this is part of a paper, is actually a page that you can click at the bottom of this page and jump and read about this AI-based system, which is very intelligent and helps a lot, specifically on the world that has shortage of laboring. It helps you controlling things without a human beings on that. Helps a lot the new industry, okay? Drones and remote sensing, very actual, very updated theme. The main objective of this submodule is to share that, use high-resolution area data to detect variability, guide precision interventions, and reduce losses. And in this case, specifically drones, they can help us by being applied on crop growth and stress monitoring, special mapping and management zones, infrastructure and landscape assessment. How it does? On the area crop monitoring with drones, this is a very updated knowledge. Drone-mounted sensors, we call it RGB, multispectral and thermal, enable early detection of emergence problems and uneven stands. If you can make use of those specific drones for agricultural purposes, you can actually send this drone to a certain point of your paddock to identify if there is a problem with the pests or disease without actually having to mobilize a team, a car, a very expensive equipment. And it helps you a lot with the early detection of emergency problems and uneven stands. When we mention uneven stands, that I have sown my corn, and one area of my corn is very uneven. I have a corn with 2 cobs here, but on the corner of my paddock, not even 1 cob. Something happened there. This can help me understanding how this uneven happening, how to diagnose on the early stages, okay? Like the drone-mounted sensors can help us detect pest disease and weed hotspots, like I said before. Rapid damage assessments after extreme weather events. This is a very important thing, specifically now, when at the middle of the summer we have a cold front coming, or the opposite, in the middle of the winter we have a hot summer, a hot front coming. This helps us a lot by helping identifying the potential problems derived from these extreme weather events. The drones, they have something very important. They bridge the gap between ground scouting and satellite monitoring. You see, they can be in the middle. The ground scouting that demands a lot of laboring, people walking on the soil to detect, for example, the diseases, and the satellite monitoring. The drones, they connect between those two. They connect both satellite imagery with the scouting on the ground. They help us a lot. They're very important too. It's very unique too. Will not be saving the agriculture, but remember, for the holistic problem, we need holistic solutions, okay? Regarding mapping and precision interventions, the drone-derived maps, they're very useful and they support delineation of management zones. You can actually, understanding the zones of a disease, you can actually delineate it, separate and seclude it, and then when the tractor comes to the application, the area won't be used because the drone has already identified you don't have to go there, or maybe you must go only there. So they help on delineation of management zone. The variable rate fertilization irrigation, by using those, you can actually define where I'll be applying this amount of fertilizer instead of that amount of fertilizer. The same for irrigation, where irrigate more, where irrigate less, where not irrigate. They help us all on targeted pest and weed control, because they are able to, such equipments are able to identify those hotspots. They can help you precision mechanical interventions by leading the tractors on the right spot and the right time, okay? And by mapping, the mapping transforms spatial variability into actionable agronomic decisions, reducing input waste and yield instability. Instead of doing a homogeneous application, or maybe irrigating homogeneously, you do the right thing on the right time on the right spot, okay? And this is a paper as well. This figure here represents a paper. This figure on the right hand side of our pages, just communicates and helps you understand how the drones, they can communicate with the base station, with them will be communicate with the tractor for decision making, and etc. This is a very interesting paper for you to read. Regarding our next subject, the data integration and decision support. This subchapter here has the main objective of transforming raw data into actionable decisions through integration and analysis. The objective is to review how important it is to transform such a data into actionable decisions. And the key elements that we'll be presenting here are related to the digital platforms and FMIS, visualization dashboards, alerts and thresholds, decision support system, which we'll be calling DSS. Okay? From data collection to decision making. Integrated platforms, aggregate sensor, drone, weather, and machinery data. Very interesting. Visualize maps and temporal patterns. You'll be able to understand by imagery what's going on in the system. Instead of just looking for plant disease, just looking for the tractor problem, or maybe for integration problem, you see it under a platform, under a data collection platform, okay? Trigger alerts when thresholds are exceeded, not just an alert for the water scarcity or maybe for the plague or problem, for the entire system, okay? And in this case, the precision, the predictive models and DSS, they act to anticipate stress and risk, support proactive interventions, and improve consistency and efficiency of decisions. This figure here on our right-hand side of the screen communicates how tech tools work together to better provide you with the right tools for decision making. Okay, from objectives to information needs to data, information, knowledge, and decision, it helps you understand. This paper showcases a tool that helps you to understand how to take a decision, how to understand how DSS, data collection, decision making, they can play in our side. Okay, the next slide is related to the chapter of preventive digital management and challenges. Digital technologies, they can enable those three bullet points, not just those three, but those three are the main ones that come to our mind when we first think about it. Early warning of stress and failures, reduce reliance on emergency interventions. Remember, if you're always on emergency intervention, mean that you're always working to remedy things, not to curate things. And this is very important for you to solve the solution on a root cause, not just by remediating things and every year have the same problem, okay? Digital technologies enable to improve resource efficiency and yield stability, okay? And the main key challenges are digital skills and training needs. We must, for us to run a system properly, we need staff well-trained. We need connectivity infrastructure gaps. In some areas of Europe is well covered by internet, but in the world, such as South America, some areas of Africa and South America and Southeast Asia, mostly in South America and Africa, the connectivity infrastructure gaps are the main challenges. Upfront investment costs is one of the key challenges because you've got to implement a system that will help you with the preventive digital management tools. So it pays itself, but you need some upfront investment. And the fourth is the data ownership, privacy, and interoperability. I mean with interoperability is that different systems, they can be operated intrinsically, they can be operated and talk to each other on a platform that actually communicates with all the different tools, okay? By addressing these challenges is essential for inclusive and effective digital transformation. And these figures here, both A, B, and C, they have been extracted from a paper that is actually the link on your written material and the link on this presentation. Just go there and click, you'll be able to access this. And it talks about how information and communication technologies can help us understanding, help us improve such a digital management tools fighting challenges, okay? I strongly support you and actually advise you to read this paper, which will help you understanding the figures of preventive digital management, okay? This was our module number 7, has been a quick introduction to the subchapters and themes. I really hope you have enjoyed this presentation. Like I said before, the main thing here is to pre-introduce you to the information that is actually more in-depth into the written material. And do not hesitate and send us a message so we'll be able to be happy to answer. And don't forget to make your exercise. That will help you fix such a knowledge. Thank you very much. I'm Professor Rafael Bonato, and I hope you have enjoyed this class. See you on the module number 8.